Hello student, how are you? Hope you all are well. So today we will discuss here about these two topics in this video: potential due to a system of charges and the derivation for the electric potential at any point due to an electric dipole. So here I will start this video. We will talk about the potential due to a system of charges. First of all, you know that when we discussed in our previous video, electric potential at any point due to a charge q is V is equals to 1 over 4 pi epsilon naught q by r. So on the same manner, we will calculate here. I draw here a system of charges, means that in a Cartesian plane, three-dimensional Cartesian plane, I am taking here a point P where we calculate the electric potential due to a system of charges, means that these point A, B, C, D, E are such that in which the charge Q1, Q2, Q3, Q4 and so on n system of charges are located with the position vector, which you can see, you can draw. See, this is the position vector of nth charge denoted by Rn. Similarly, this is the position vector of first denoted by R1. This is the position vector for second denoted by R2, and so on. You can draw the position vector of each individual charges. So here if I try to draw this is our R4 denoted by, and on the same pattern this we will left here because the diagram will draw here. So leave this, no problem. Similarly, Q3 can locate it. If you want to draw this, so you can also draw the location of charge Q. The position vector of charge Q is denoted by like this. So these are the point charges located in a system of charges, and we want to calculate the electric potential difference due to these all charges, individual charges at any point P. For that, what we will do, we will join the point A to point P first. Point A to point P first. Either you can draw this diagram in simple way like that. Suppose this is our charge P and this is the point A, and we know that the position vector of point A is R1 and the position vector of this point P where we want to find the charge is noted by R0. So the distance between A and P is the distance between the point P and the charge Q1. Now here we will find the electric potential due to this charge Q1 at point P. In the same manner, we will calculate the electric potential due to n charges after joining their location with the point P in as we join in first. See, now electric potential at P due to charge Q1 as shown in diagram. What we will? It will be V1 is equals to 1 over 4 pi epsilon naught Q1 upon R1 naught. See, what is the distance between them? By the vector addition, if I will try to show you, let this is R1, this is our R2. So AP vector is noted by OP vector minus OA vector, and see the OP location is R0 and OA location is R1. So we will discuss here about the point AP, which we can write R10 or 10. So here R10 is the position vector, means position vector of AP. So here this is our R10. Similarly, if we want to find the electric potential at any point P due to charge Q2 located at which point? B. Then we again follow the same procedure as we proceed in A. join the point here. This is a position vector of charge R2. So the point VP is denoted by R2 naught. This is located by like that. So here we can say that electric potential at P due to charge Q2 denoted by V2 is equals to 1 over 4 pi epsilon naught Q2 upon R2 naught. Similarly, in the same manner, we can write V3. Similarly, we can write V3 is equals to, means that V3 means electric potential at point P. You can see electric potential at point P due to this charge Q3. Electric potential, similarly we can do electric potential at point P due to Q4, Q5, Q6, Q1, Qn up to n. So here electric potential at point P due to charge Q3 is denoted by V3, which is equals to 1 over 4 pi epsilon naught Q3 by R3 naught. And so on. After following the same process, we can write electric potential at point P due to charge Qn, which is noted by 1 over 4 pi epsilon naught Qn upon Rn naught. So after that we will see the total electric potential due to a system of charges. Here we will calculate the total electric potential due to a system of charges Q1, Q2, Q3, Q4, Q5 and Qn at point P is the sum, means with the help of superposition principle we will write is the sum of all individual electric potential at that point. So here by superposition principle we can write total electric potential at point P due to a system of charges V1, V2, V3 Vn. V1 is equals to, you know that 1 over 4 pi epsilon naught Q1 upon R1 naught plus V2 is equals to 1 over 4 pi epsilon naught Q2 upon R2 naught Vn is equals to 1 over 4 pi epsilon naught Qn upon Rn naught. So by using superposition principle, what we will do, taking after this we will take 1 over 4 pi epsilon naught common Q1 upon R1 naught plus Q2 upon R2 naught plus Qn upon Rn naught, and taking a summation, algebraic sum for that value, which will start from I is equals to 1 to I is equals to n, and we will write here Qn upon Rn. I will write here summation sign which will start I is equals to 1 to I is equals to n Qi upon Ri naught, and in outside 1 over 4 pi epsilon naught work as a constant. So it is our total electric potential at point P due to a system of charges. So listen here, this is not a big deal for you. So here main concern is that here we will take different type of individual charges, means that Q1, Q2, Q3, Q4, Q5 and Q on, and make a system, and we want to find electric potential at any point in this case. So by using superposition principle we can easily find the electric potential at any point P due to a system of charges, as we have discussed in front of you. So please pause the video and note down. So here students, after getting the value of electric potential at any point due to a system of charges which was V is equals to 1 over 4 pi epsilon naught Q I over R I naught with summation sign I is equals to 1 to n. So if we want to write this formula in form of position vector, so we can write this I naught means that we can say this magnitude of the distance Ri naught is equals to mod of vector Ri naught, or you can say that mod of vector R naught minus vector Ri. As I discussed earlier, R1 naught is equals to R naught minus R1. So on the same way, we can write here Ri naught is equals to R naught minus Ri. So either you can represent in vector form. Vector form means position vector form. You can write V is equals to 1 over 4 pi epsilon naught summation I is equals to 1 to n Qi mod of R I naught, or you can write 1 over 4 pi epsilon naught summation I is equals to 1 to n Qi over R naught minus Ri of vector. This is the final calculation of electric potential at any point due to a system of charges. And after that, you know that after this, you know that electric potential is a scalar quantity. So if we want to find their dimension formula for electric potential, then you know how you will find electric potential is, see, you know that commonly V is equals to W upon Q. So you know that W is the work done, whose dimension formula ml square t minus 2, and here Q is a charge which is equals to I into T, means current into time. So I will write here A into T form. So after that, after solving this, we will get here m L square T raised to the power minus 1 A raised to the power minus 1. See here, m L square T raised to the power minus 3 and A raised to the power minus 1. This is the dimension formula for the electric potential. So here, after this video, finding the formula of electric potential at point P due to a system of charges, here I am giving you some practice question related to the system of charge particles and two charge system particle, three charge system particle. You will do the question in your pair notebook. Thank you. Have a nice day.